Land navigation is the ability to determine where you are, identify where you need to go, choose a route, and arrive at the correct location. A reliable navigator does not depend on one method alone. They combine the map, compass, protractor, pace count, terrain association, and sound judgment. Your basic navigation tools are a military topographic map, a protractor matched to the map's scale, a lensatic compass, writing materials, and a pace count system. A topographic map shows more than roads and trails. It shows terrain shape through contour lines, elevation, vegetation, water features, man-made features, and grid lines. Before navigating, inspect the map's marginal information: scale, contour interval, date, and declination diagram. A compass points toward magnetic north. A map's vertical grid lines point toward grid north. Grid north is established by the north-south grid lines printed on the map. Magnetic north is the direction indicated by the compass needle. The difference between grid north and magnetic north is called the grid magnetic angle, or GM angle. Always use the declination diagram printed on your specific map. It tells you whether magnetic north is east or west of grid north and provides the conversion information needed for your navigation problem. Do not guess the GM angle. It changes by location and can change over time. The lensatic compass uses two common angular systems, degrees and mils. A full circle contains 360 degrees. A full circle also contains 6,400 mils. Use degrees when your azimuth is issued in degrees, such as 090 degrees. Use mils when your azimuth is issued in mils, such as 1600 mils. Use the same unit throughout the navigation problem. If the mission gives you degrees, remain in degrees. If it gives you mils, remain in mils. Hold the compass level and keep it away from metal, electronics, vehicles, and other sources of magnetic interference. An 8-digit grid coordinate identifies a point within a 10-meter grid square. Remember the rule: read right, then up. First, read the vertical grid line to the left of the point. This is the easting, or right reading. Second, read the horizontal grid line below the point. This is the northing, or up reading. For an 8-digit coordinate, the first 4 digits are the easting. The last 4 digits are the northing. In the example, 12345678. 12 identifies the larger easting grid line. 34 estimates distance right within that grid square. 56 identifies the larger northing grid line. 78 estimates distance up within that grid square. Use the correct protractor scale for the map. Place the protractor's 00 point at the lower left corner of the grid square. Keep it aligned with the map's grid lines. Then measure right and up to plot the point. After plotting your known location and destination, draw a straight line between the 2 points. Place the protractor's center hole over the start point. Align the protractor with a north-south grid line. Read the angle from grid north to the destination line. That angle is your grid azimuth. Before navigating with your compass, convert the grid azimuth to a magnetic azimuth using the GM angle from your map's declination diagram. A pace count helps you estimate distance traveled on the ground. Establish your personal pace count on a measured 100-meter course. Many navigators count every time their left foot strikes the ground, but use the method taught by your instructors and remain consistent. Your pace count may change because of terrain, slope, vegetation, equipment load, fatigue, weather, and visibility. You should establish both a day pace count and a night pace count. At night, reduced visibility, slower movement, cautious foot placement, and the need to identify obstacles can change the number of paces needed to travel 100 meters. Do not assume your daytime pace count will remain accurate at night. Record both counts in your notebook and use the count that matches the conditions you are navigating in. For example, if your night pace count is 70 paces per 100 meters and your planned distance is 500 meters, your estimated total is 350 paces. Track each completed 100-meter interval using pace beads, knots, or another consistent system. Recheck your pace count when terrain or conditions change significantly. Dead reckoning means moving from a known location along a planned direction for a planned distance. It combines three essential elements: a correct azimuth, a reliable pace, count a known starting point. Use an aiming point whenever possible. Select a visible feature on your azimuth, move to it, then select the next aiming point. This is more accurate than trying to walk while staring at the compass. A 90-degree offset is a deliberate method for bypassing an obstacle while maintaining your original route. If you cannot move directly forward, move 90 degrees to one side and record the distance traveled. Move parallel to your original azimuth until you have passed the obstacle. Then move 90 degrees in the opposite direction by the same recorded distance. The purpose is to return to your original line of travel without losing your position. Use deliberate, simple navigation methods. Record your actions. Do not rely on memory alone. Terrain association means matching what you see on the ground with what you see on the map. It is one of the most important navigation skills because it gives you continuous confirmation of your location. Look for identifiable terrain features including hilltops and ridgelines, valleys, draws and saddles, streams and water crossings, roads and trail intersections, vegetation changes, buildings, power lines, and other mapped features. Use terrain association together with dead reckoning, not instead of it. If your compass, pace count, and terrain do not agree, stop and reassess your location before moving farther. Use this navigation routine. Inspect the map and declination diagram. Plot the start point and destination. Determine the grid. Azimuth, convert it to a magnetic azimuth. Calculate distance and expected pace count. Identify terrain features and checkpoints along the route. Move using compass direction, pace count, and terrain association. Record offsets and correct errors early. Confirm the destination using multiple indicators. Successful land navigation is not about trusting one tool. It is about checking your work continuously. Plot accurately. Convert carefully. Know your day and night pace counts. Use terrain. Maintain accountability. Follow current doctrine, qualified instruction, and unit SOP.